Good morning. Wait, is it morning? Or, no, this is a video. You can be watching it whenever, so. Wait, I'm recording it at 6 p.m. Wait. No, I'm joking. I'm writing the script at 1:40 p.m. Anyway, enough dally. Today's lesson is in physics. Kinematics. Okay, first off, what is this? It's, simply put, the study of motion. See, over time, things can change position. When something changes position over time, it's called velocity, which means that velocity, in terms of units, is distance over time, like meters per second, feet per minute, skittles per Planck second. The rate at which velocity changes is called acceleration. Okay, this equation is related to velocity in the way that it is the derivative of the velocity equation, and that's calculus, but not everybody likes calculus. Sounds complicated and scary. Let's say exactly how it is, but trust me, that's the relationship between the two equations. Okay, quick little break, real quick. I know we just started, but here's a bee that I made from fabric. Let that sit for a second. Just kidding, this is related to physics because the bee's first initial velocity is 0, starting at the position here. The position after 3 seconds is here. Therefore, the bee is traveling at exactly 0 miles per hour. Staggering, I know. Okay, back to analysis. There are 4 main equations that can be used to describe motion in one direction over time. And as pictured on screen, these are very nice equations that you can use to answer a bunch of questions given to you by your high school physics course professor that you're close to failing because he doesn't teach since he has ADHD and your class is slightly rowdy, so the first chapter turns into the first semester and you're stressing because you actually want to pass the test later on. Okay, here's some stuff we can do with the equations. First, we need to understand that all these equations can be manipulated. For example, let's say we want to find the distance that the bee has to travel before it hits the ground if it takes 6 seconds to hit the ground. If we know the starting and final velocity, we can plug the numbers into this equation. If we already know the starting velocity and the acceleration, we can plug and chug into this equation. But when we need to find some other things like time, we can rearrange the equations to isolate the variable we want to know. And bam! This is time if we know the rest of the other stuff. Okay, break time. It's time for real. I want to share this lovely kazoo. It's from Nashville. I'm proud to own it. I can play hot cross buns on it. Not one lesson. Finally. This has just been a basic rundown, really quickly, into what you can do with these complicated-looking equations. A method you may know to be able to use these things effectively is to write down a list of known and unknown variables. Because, as you may notice, not all the equations need all the variables. This one doesn't need acceleration. So, trying to figure something out, you can use the different equations based on what you do and don't know. So maybe write down a list. I just said that. Okay, and if you can't figure it out, I don't know, call me. Or look at more videos online about physics. The internet's a great resource. And I might have some stuff coming up soon, too, so look forward to that. Bye.